Hi friends, this is me, Dr. Jagdish Jagtap, and today we'll start with our series of studying the G C Leong textbook, and I'll start with the chapter Oceans. So these are the subheadings. We'll be exploring the oceans, then the relief of the oceans, oceanic deposits, salinity, temperature, movements of ocean water, and then the movements of every ocean in detail. Well, if we are to explore the oceans, 70% of the area of the earth is covered by oceans. So this is no news to us because we know this. Secondly, this ship Challenger was the first expedition sent for oceanographic investigation. Oceanography as such is the science of oceans. Then we have this International Council for Exploration of the Sea, which is located at Copenhagen. Earlier, we used to use those older eco techniques, the ones which we learned in school textbooks and all. But nowadays, this technology is replaced by radar sounding and electrical eco devices. And there is one very easy practical method to observe current flow. What they do is they throw sealed bottles into the sea. This bottle is thrown into the sea. It has a note written that whosoever finds this, please return this bottle to so and so address, and with the time and location of where you found it. And from this they come to know like from where the current is flowing to where. Coming to the first subheading, that is the relief of the ocean floor. First we have this something called as the continental shelf. If this is the sea level, this area here, this is called the continental shelf. The seaward extension of the continent from shoreline to continental edge. This much extension is called as continental shelf. It has a gradient in 1 in 500, and the Arctic shelf has a very large continental shelf that is 750 miles. Well, what is the geographical significance of such shelves? Well, first thing is that it is shallow. It means that there is greater penetration of sunlight, which means that there is larger growth of plankton, which results into richest fishing grounds. Examples are Grand Banks. Now this is the Grand Banks. This is located at the eastern side of Canada and between Canada and Greenland. So this is this Grand Bank. Secondly, we have the North Sea. This is Great Britain. This is Norway, and this is the North Sea. Then we have something called as Sunda Shelf. This is Indonesia, and the shelf near Indonesia is called as the Sunda Shelf. Well, the limited depths keep out cold undercurrents. This we can understand. Secondly, since the depth is limited, the height of the tide rises. Well, ships can only enter or leave the port on tide. So this can be a disadvantage. Yet, great ports like Southampton, London, Hamburg, Rotterdam, Hong Kong, Singapore are all located on continental shelves. Why? I tried to find this answer, but I couldn't find this. That why is it so? If someone finds it, please write in the comments. Then the second part is the continental slope. This slope, like we understood the shelf as like this. Then from this point we have a slope. This is the sea level. So this is the continental slope. Then we have something called as the deep sea or abyssal plains. These are extensive plains under this in the ocean bed. Initially they were thought that these deep sea plains have no features, but later on we came to know they have many features like plateaus, ridges and all, and some islands also. These have been given in G C Leong. I have tried to plot them. Now this is Azores Island. This is Azores Island. It belongs to Portugal. And then this is Ascension Island. It belongs to UK. Now these are random islands, but since they are mentioned in the book, they might be asked. Well, then something called as ocean deeps. Now suppose this is the shelf, this is the slope, then there is something called as trench. Now this is the trench. These are the ocean deeps. This is the sea level. Well, then we know that the deepest trench is the Mariana Trench, and the Mariana Trench contains the Challenger Deep. Challenger Deep. Then this is the Mariana Trench. Then this is the Tonga Trench. We have to remember a few. This is the Tonga Trench located near Australia. This is the Philippine Trench. The Mindanao Deep is also called as the Philippine Trench. So these both are the same. Then we have something called as the Coral Trench. Then the Aleutian Trench. Yeah. These much are sufficient. These many are sufficient. We can observe that these trenches are mostly located near the continents. You can see here also. Even we might think that this is located in the sea, but this is actually a continental shelf. It is a submerged continental part. So they are located near the continents. The reason is because suppose this is one plate, this is one plate, this plate subducts below the other, and this causes a trench formation. This trenches are formed. So this is the trench formation. Well, the oceanic deposits in the ocean floor are of three types. First, there are sediments. These are terragenous, that is, they are deposited by the rivers, and they have been brought from the terrestrial portion, that is the continents. Secondly, we have the oozes. These are pelagic deposits. Pelagic, which means that they are formed in the ocean only, like the ocean given. Thirdly, we have clays, and they have been given by the volcanic dust. Now coming to the salinity of the ocean water. First thing we have to know that it contains sodium chloride till 77%. And this ocean water has the same proportion of salts relatively, but the degree of concentration varies. Because of this, the salinity varies. And there is something called as the isohalines. These are lines joining places having equal salinity. Just as we have isobars, in the same we have isohalines. Well, the average salinity of seawater is 35 parts per thousand. The highest salinity observed in Lake Van, that is 330 parts per thousand, and the Dead Sea, as we all know, has 250 parts per thousand. Then what are the factors which control salinity? First is the rate of evaporation. Well, higher the salinity will be there where near the deserts, near the tropical deserts, the humidity is very low and temperature is high, so there will be a lot of evaporation, and that will cause higher salinity. Secondly, when amount of fresh water added is more, their salinity will decrease. Now in the equator there is constant rain and there is high humidity, so there is less evaporation, that is why less salinity. We might think that the equator has more salinity, but it is not so. It can be a trick MCQ. Secondly, the influx of large rivers like Ganga, Irrawaddy, Amazon, Congo, they also decrease salinity because of fresh water supply. And then melting of icebergs, that is in Baltic Sea, also the salinity decreases because of fresh water supply. Then there is something called as degree of water mixing by currents. Now if a sea is closed, then there is no incoming water, so that is why this salinity will increase. Compare this with an open water body where water is coming inside, going outside. Here salinity will always be less. Now let us come to the temperature of the ocean water. Well, the one thing we know for sure, that as we go towards the pole, the temperature of ocean water will decrease. but this decrease is never constant. Why? Because of currents, winds, and air masses. Now there is this part of how cold currents affect the ocean surface water and how the warm currents affect the surrounding land. We will discuss this in the next few slides. Let us keep it aside for some time. Let us come to this. Highest temperature are found in tropics, and pack ice in Antarctica and Arctic melt, and that causes reducing temperature of the sea. Well, then what are these factors which affect the ocean water movement? First is planetary winds. They could be the westerlies, they could be the trade winds. Then second is the temperature. Water will go from, like warm water will be at the surface and cold water will be at the base. So if there is cold water, it will sink below and warm water will take its place, and then this cold water will come here. So this cold water will move at the floor of the ocean and warm water will move at the surface. Then salinity. Water will move from a place of lower salinity to a place of higher salinity, because like wherever there is higher salinity, the water will sink down and that place will be taken by the lower salinity water. And then the same thing, just as what happens in the case of temperature, the same thing happens in case of salinity. Then there is something called as rotation of earth, which causes a force called as Coriolis force. Exact effect we will learn in the next slide. And there is something called as land effect. Now suppose this is Brazil and there is this equatorial current coming. It gets split into two parts. One is the Kenyan current and second is the Brazilian current. This also we will learn in the next slide. Now we will learn the oceanic circulation of the Atlantic, Pacific and Indian Ocean. Here first let us look at this Atlantic Ocean. Now here we have this north equatorial current, we have the south equatorial current, and in between of them we have this counter equatorial current. This much we can understand. Now let us first study the north part. Now this north equatorial current is deflected here. Here it is called as the Gulf Stream. Then this is again deflected towards its right, and because of the winds we have the North Atlantic drift, and this drift carries warm water towards these areas, and that is why this coast has ice-free ports throughout the year. Now once the cold water will migrate from the poles towards the lower latitudes. So here we have this is the Labrador current, this is the Greenland current, or the Irminger current. And these two, and then we have this Canary current, and then this again comes back to the equatorial current and it forms a complete cycle. Now there is something called as the Sargasso Sea in between. Sargasso Sea. Now this sea is an apparent body of water which has no perceptible movements, and lots of trash seaweed gets accumulated here. So just remember that this is the Sargasso Sea. Now applying the same logic to the that is the southern Atlantic Ocean. So here we have the south equatorial current, then we have the Brazilian current, then we have here the South Atlantic drift, and then we have here the Benguela current, which will be the cold current. The ones which I have marked in blue are cold currents, the ones which I have marked in red are warm currents. Now let us apply the same logic to the southern Pacific Ocean. According to this logic, here we will have a cold current, which is called the Humboldt or the Peruvian current. Yeah, again applying the same logic, we will be having a cold current here, which will be called the Californian current. Going by this same logic, we will have this equatorial current, north equator, south equatorial current, counter current. This north equatorial current will go like this. It will form the Kuroshio current, and here it will form the East Australian current. Then from the northern side, we have a current coming here, which is called as the Ocasio current. So here the cycle is complete, and just for the sake of completion, we will be having here South Pacific drift and North Pacific drift. Now applying the same logic to the Indian Ocean, we'll have a warm current here, that is the South Equatorial current. Then one more here, that is called as the Agulhas current. And then it will come here like this. It will be the South Indian Ocean current, and now this current will change its like this. It will be a cold current. This is the like this is the East Australian, this is the West Australian current. And then there is one more classic thing which happens is, in the Indian Ocean, due to the monsoons, suppose this is the pattern here. So during the northeast monsoons it is like this, during the northwest monsoon it is like this, but this pattern is reversed during the northeast monsoons. So this is a classic example how winds determine the ocean currents. So that's about it. Thanks a lot. Have a great day ahead.